All right, guys, we've got a fun video today. These are two adiabatic demagnetization refrigerators. These use something called a pulse tube cooler to get you down to about 4 Kelvin, and then have a 4 Tesla magnetic field from a superconducting magnet that cools down 2 salt pills down to temperatures of about 50 millikelvin. So this is an alternative way to get cold besides the dilution refrigerators we've already showed you, but this is much smaller. You saw that dilution refrigerator was a huge thing that we've been working on. This is a really compact system. So when we go to a telescope, like the Subaru telescope in Hawaii where we do a lot of our work, we want something smaller. So this is a nice way to bring a small system. So today we have two unknown ADRs. These came from a colleague of mine, Professor John Martinez, who does quantum computing. He's not using them anymore, so we're taking them over. And we have no idea what's in them. They haven't been opened up for 6 years. So this is an unboxing video, and we get to see what's inside these ADRs. So I'm going to come and give you a little closer look here, and then we can start the process. All right, so this is the first one. You can see this one has some DC connectors. So there's 2 connectors up here to bring 24 lines of DC in. And then there's 8 SMAs. So this was clearly used for testing. We just don't know what's in it. So we're gonna basically go and open it up and figure it out. And we actually have a second one too. This one over here, you can see them next to each other. They're the same unit. But this one has 8 SMA connectors right here. And it also has, hard to see it, 8 SMA connectors right here. So we have 2 fridges that are clearly have different wiring. This one's called Quaid, and this one, actually we also have this box here. I think this is the thermometry box, but we'll find out. All right, so the first step, we got to get these open. So we managed to salvage the mount for these. They essentially attach to Unistrut. We don't have something perfect in our lab, but we do have some Unistrut. So we'll try to get Unistrut that works and then hang it up, and then we'll drop the shields and see what's inside. All right, so we're now going to try to put the Unistrut mounts on the wall. This wasn't how they were designed, so we might have a little work to do. All right, hey Ronald, you want to give me a hand? The best laid plans of mouse and men. All right, we got Joe has responded. Joe, you want to hold this up so I can get this screw in here? Okay, should be able to go. All right, we got to find a little spacer to go over there, but we can put the second one on and then worry about the spacer to distribute the load on the wall. All right, cool. Now we can figure out about 1 inch. All right, we need something about 1 inch to keep that from collapsing. It's actually Friday afternoon, so I'm going to go home, machine some wooden blocks to about 1 inch. Then I'll use those as spacers to keep the bottom spaced properly. So on Monday, we'll be ready to go. Okay, it's Wednesday morning. Had 3 huge NASA proposals to get out the door. So those are all done. Yay, those are my big proposals for the year. But we're gonna get back to trying to see what's in these adiabatic demagnetization refrigerators. So last time we'd been working on getting a setup that would work to anchor us to the wall. Unfortunately, we don't have the right Unistrut configuration, so this isn't going to work. There's a big gap. So I went home and I had a nice piece of maple, about 1 inch thick. So I cut these to size. We're going to use these behind the cantilevers in order to support them. So I'm going to figure out how to mount this, and then we'll get going. All right, so the problem is that the cantilever flexes, and so the weight is still being transmitted into the top strut. So we need to stop it from sliding. A screw is one option. Since this is a temporary setup, I'm going to try some double-sided tape. If that works, we're good to go. If not, we'll put some screws in there. 0% success. All right, screws it is. One of the nice things about working in a physics lab that's well stocked, when you need some screws, well, you can see we've got, say 632 by 5/16. Oh, you say you want it in brass? Oh, well, here's our brass screws. In this case, we want wood screws, something like a 1 inch. We'll give these a go, see how it works. The goal here is going to be to just screw the this metal piece to the wood, and then the wood is pretty much not moving, but if it does move, then the double-sided tape would probably be good on the back of the wood. My goal is to try to not put any holes in the wall that I don't need to put in the wall. All right, in order to keep the wood from cracking, we're going to need to drill a pilot hole, but I don't have good access, so I'm going to mark the location, drill pilot hole, and then put it in. All right, it looks like no matter how much I want, we're not getting away without putting a hole in the wall, so let's do it. Definitely will hold the weight. I will give it a better stress test when we're done. I like to stress that if we were doing this permanently, this would be a better mount, but this is just a test to let us open the fridges safely. So let's try this again. That's the unistrut coming off the wall. Let's give it a try. Whether I like to admit it or not, I'm significantly heavier than these doers, so we'll put some weight on it and see how it looks with the fridge on it. All right, so got some screws that go in here, so I'll position those and then we'll see how we're doing. Okay, for all my bragging, we needed 3/8 inch screws, which we didn't have in the lab. We only go up to about a quarter 20. So we'll use these 3/8 inchers and we'll see how it goes. So those little rubber things on top are shock absorbers designed to reduce the amount of vibration that's transmitted to the doer. Overkill for what we're doing. All right, we're gonna put the weight on it real slow up and see how it goes. It didn't fall yet, so I'm gonna call that a victory. All right, so we've got the fridge hanging, and we can now take off the shields. See how it looks. I'm gonna leave the lift here to help make this work. Now, this could very well be under vacuum. We haven't cracked the vacuum yet, so let's do that first. All right, I'm gonna open up the main valve, see if it's under vacuum. It is under vacuum. Wow. That's been under vacuum for years and years. It's a good sign. There's one component in the ADR, which is a paramagnetic salt pill. It's ferric ammonium alum. We call it FAA. And that salt pill is hydroscopic. It's sealed in a stainless steel container and welded in it, but if it develops leaks and water gets in, it gets destroyed. So having the vacuum is a nice little extra protection. All right. So vacuum's broken. Now we can remove the shields. These fridges have a really nice system. So instead of having to take off a million bolts, we can just open up these clamps. So I'm going to bring this up a little bit to support it. There we go. Now we're going to open this. Oh yeah. All right. Now we should just be able to lower the shields off of it. Let's see. Oh. Nice. So we've removed the 50K shield, or the room temperature shield. We can see a little bit now on the fridge. There's these coaxes, which were not made extremely cleanly, but we can live with that. So these are stainless steel coaxes that are going down to 50K. And let's see what else we got. These are just blank flanges. These are the magnet wires that bring the high current into the magnet. Then there's this huge, so these connectors here are wired up to a big, oh yeah, see this cable right here? I'm not sure if you can see it, but there's a loom cable, which is it's attaching here. This is a cryo loom cable. So there's at least 24 conductors going down to lower temperature stages through this pass-through right here. All right, so what we need to do now is we need to take out these screws to drop the next stage. We can do this with one person if we use the lift, or we can do it with 2 people and drop it. So I'm going to put some gloves on and we'll decide how we're going to do it. We're going to use the lift to make this a one-person job. All right, we're free. We'll start lowering it down. This is the 77 Kelvin shield. Nice and light, nickel-plated aluminum, I think. All right, so let's see what we got now. So our stainless steel coaxes are going through the 50K plate, and they're terminating here in SMA connectors on the 4 Kelvin plate. There's also some feed-throughs over here which are not being used and are being taped up. This is the magnet pass-through. And the DC connectors here, you can see this loom cable. This is bringing the at least 24 connectors down here. Now, one thing we've noted, we've got a bunch of tape that's loose. We've learned the hard way that you got to have all the holes sealed up going into 4K really well. So this loose tape all needs to be replaced before we do anything with it. But yeah, looks good. Nice, simple ADR. We'll now take off the 4K stage. Conveniently, it uses the same 440 screws for both the 4K and the 50 Kelvin shield. This is a pretty easy fridge to work on. HPD did a pretty good job engineering it to make it pretty straightforward. Sometimes there are an awful lot of holes here, but you don't have to use them all clearly because they're only using about 1 out of every 3 of these holes on the bolt circle here, screw holes. Okay, that should be the last one. You can see it's releasing. So the moment of truth, we're going to drop the 4K shield and see what we've got at base temperature. Here's the 4 Kelvin shield. You see the inside is painted black. That's usually an Aeroglaze Z306 epoxy paint. You can't just anodize it or use unanodized aluminum because those don't absorb at the infrared wavelengths. You need a paint that's black in the optical but also in the infrared. All right, we scored. All right, so this is the ADR here. These are the coaxes that are coming down. Right here is a low noise factory LNF 4 to 8C. This is a nice hemp, about $7,000. It has a noise temperature of about 2 Kelvin. So that is essentially what we're going to be using. We can move this out of the way. All right, so we've got the ADR, which is the cooling system. Is this? It's actually these Kevlar suspended pucks. It's a cool system. We'll show that in another video. We've got the low noise factory amplifier that's reading things out, and then down here we have a surprise. There's an experiment still in here. This is a magnetic shield. So this is something like a mu metal magnetic shield. Let's take that off and see what's in there. All right, I got the right screwdriver. Now we can take this magnetic shield off and see what's underneath it. There's 2 different things. So I got to take off only for the outer shield. So this is a 2-piece magnetic shield. One piece that's designed to be removed every time you change your experiment, and then a base plate that looks like it's designed to stay on between experiments. So we will try to only take off, that's the removable side. Let's drop the magnetic shield. All right, so what we got in here, auxiliary plate that's going to be at the base temperature of the fridge. And then this is an interesting design. Yeah, these are just the coaxes coming up. I see that. Okay, so this is all floating. There's one big box here, probably an isolator. And this is the Martinez old design quantum computer chip. So I think that's that's some kind of qubit in there just for testing purposes. All right, that looks great. Now, where does the DC wiring come out? Let's see. There's the hemped amplifier right there. This is where, so this is the DC wiring. The DC wiring, this is the DC wiring right here. So this only is breaking out to this pad here. So these are all the wires that are coming out that are, most of these are actually look like they're reading out the thermostat on the fridge, although there's this breakout here. So this is probably amplifier bias and thermometry wires here. Yeah, here's the hemped power. This one has a copper sleeve and it's soldered in here. I'm not sure if you can see that. This is a niobium tie coax. It's a superconducting coax. And you can see there's a couple of them going. This is probably copper nickel right here. Really, a fully functional refrigerator here. This looks great. I think we're going to be able to repurpose this really easily for MKID measurements. So that's the first one. We actually have another one of these. I'm going to close this one up and we'll eventually look at the second one. All right, thanks for joining us, everybody. Remember to like and subscribe.